In this video, we're going to talk about two different types of asymptotes. We've already talked about the vertical asymptote, but I also want to point out that there's this thing called a horizontal asymptote. So with asymptotes, we want to think of asymptote as something, it's a value the function approaches. For a vertical asymptote, this here is the same thing as a restriction. That's critical with our vertical. Our denominator cannot be 0. And our horizontal, it's just simply something the function gets close to. So I have actually written down 3 different rational functions, and we're going to look at them one at a time. So if I look at this first one, if I'm looking for vertical, I'm always going to look in the denominator. So right here, my denominator cannot be 0, so I have to check for a restriction. So I'm going to look for a restriction in the denominator, and I find that if x were to equal 3, that's a restriction, so that there is my vertical asymptote. And I'm going to abbreviate vertical asymptote VA. So I have a vertical asymptote at x equals 3. I also have a horizontal asymptote, and I want to show you a way to remember that. But first, let's just look at the graph. So when I graph it, this is what this particular function looks like. So let's just go ahead and we're going to go ahead and sketch what this particular function looks like. So I say I'm sketching because I'm not really too concerned about the exact particulars, with the exception of the vertical and horizontal asymptote. So I already know I have a vertical asymptote at 3. So right here I'm going to declare this 3, and I'm going to put in my vertical asymptote. So my function cannot cross that line. That is a mark in the sand. Not allowed to cross that line. But if I look at my function, it looks like also that I might have a horizontal asymptote about here. So I'm going to actually do something in my calculator to maybe help you see that. So there's a draw function here in the blue. So I'm going to go second and that programming button, and I'm going to draw a horizontal line, which is number 3. So you can see it put in the horizontal line at y equals 0. If I move that line up, you can see that it looks like on either end, my function is approaching that line. That looks like it might be somewhere around y equals 2. Remember, this is just an approximation. I cannot get the calculator to tell me exactly what that value is. So that looks like I might have a horizontal asymptote at y equals 2. And in fact, I do. There's a way that I can use my function to determine. So let's look at this closely. So I have a 2x, and then I have an x, and then I have this minus 3 at the end. I really don't care about that. That's just extra stuff. What I'm going to look at is I'm going to look at my highest degree of my numerator, which is 1, and my highest degree of my denominator, which is 1. So if the degrees are the same, so it's the same degree function, then I know that my horizontal asymptote, which I will label that HA, that's my horizontal asymptote, is simply going to be the ratio of the lead coefficients, which is right here. So I have to recognize that there is a coefficient of 1 right here. So that means then that my horizontal asymptote is 2 over 1, which simplifies to 2. And because it's a line that goes horizontal, that is going to be y equals 2. And in fact, we saw that in the calculator. So I can write that I also have a horizontal asymptote at 2. So right here, I'm going to mark this as 2, where my y equals 2, and I have a horizontal asymptote. So that there just gives me some guidelines on how I'm going to sketch this function. So I know that this function comes around like this, and I also know that this function comes around like this. So remember, this is just a sketch. Okay, let's look at the next example down here. So the first thing I need to ask myself is, do I have a restriction in the denominator? So let's look for a restriction, and our restriction will give us our vertical asymptote. So in order to find the restriction in this, it's a quadratic, which means I need to factor this. So I have to factor that denominator. And when I factor that denominator, I am going to get x minus 3, x plus 1. So that's, if I were to go ahead and factor that out, that would be what my factors are. So that means that I have a restriction. So that means my restrictions are the same thing as my vertical asymptote. So my vertical asymptote is going to be where x is 3 and where x is negative 1. Those are the values x cannot be, because then I'll end up getting a 0 in the denominator. So let's go ahead and let's just take a look at this in the calculator. So I'm just going to do this the old-fashioned way, and I'm going to put the numerator and the denominator in parentheses to do this, to graph it. And so I go ahead and I graph it. Okay, and again, don't get freaked out at what you see. It's no big deal. These are just rational functions. Sometimes can give you odd-looking things. So we can see it looks like there's probably a vertical asymptote here and a vertical asymptote here. And if we can see, that's where x is negative 1, and that's where x is 3. And that's the fact what we found right here. The other way I could look at this is I can go to my table, and you can see where x is negative 1, I get an error, and where x is 3, I get an error. So those are restrictions. Those are my vertical asymptotes. So let's go ahead and sketch this. So I'm going to go ahead and I'm going to sketch my x and y axis. And again, I'm not really all that concerned with too much accuracy. I just have to make sure that I know that I have an asymptote where x is negative 1 and an asymptote where x is 3. So just for the sake of this video, I'm just doing a sketch. Not too concerned about being totally accurate everywhere. I just want to get an idea. So these are my vertical asymptotes. Those are restrictions. So now I have to ask myself, do I have a horizontal asymptote? When we look at this graph, yes, we do have a horizontal asymptote. Now remember, when we think about where does this function approach, typically we think about the end behavior as x is going to negative infinity or as x is going to positive infinity. So it looks like it's kind of hugging our x-axis. And our x-axis is where y equals 0. So it looks like I also have a horizontal, where y equals 0. It looks like I have a horizontal asymptote right here. So I'm just going to do that in yellow because it's actually our x-axis. Okay. So that means that when the horizontal asymptote is actually where y equals 0. So I gave you a little trick up here. This one here, I looked, are the exponents, are they the same degree function in numerator and denominator? And the answer was yes. But if I look here, my degree is different. I have a bigger degree on the bottom, right? So excuse me with this, but when I look at this, let's just look at our, again, the Lie coefficient. I have x. I don't really care about that minus 2. That's kind of irrelevant. And then I have x squared, and I don't really care about the negative 2x minus 3. I'm just concerned about my degrees. So that has a 1 degree. So if it has what I would call a big bottom, which this does, it has a big bottom because the exponent is bigger on the bottom. I'll say exponent is bigger on the bottom. Okay, so excuse this, but I worked with a teacher who this seemed to help students remember. So if you think of a big bottom girl, you go, yo. So what does that mean? That means y is equal to 0. And I apologize if I've offended anyone. I'm just trying to think of a strategy to help you remember. So when you have a bigger exponent on the bottom, that's a yo, where y will always equal 0. Okay, so now let's just go ahead and sketch this in before I forget. So when we're looking at this, this means that my function is going to come around like this. It's going to get really close to that vertical asymptote. This kind of comes around like this. Again, it's a sketch. And then this comes around like this. So one of the things we like to do with these functions is we do like to look at end behavior. And here my end behavior would be y approaches 0. Y approaches 0 on either end. Let's just go up and just let's look at this. Here my end behavior on the right would be y approaches 2. And on the left would be also y approaches 2. And we can play around with that concept. I just wanted to introduce that to you. So the last one that we're going to look at, and we can already see it looks a little different than the other ones. Notice the exponent is on the top. So this one here is top heavy. It's not going to be this. It's going to be different. But before I get ahead of myself, let me see, do we have any restrictions? We have to look here. So do we have a restriction? Because if we have a restriction, that means we have a vertical asymptote. So what would make x, what value of x would make this 0? Well, that would be where x, my vertical asymptote, will be where x is equal to 5/2. So that's a vertical asymptote. What did I do? I set this equal to 0 and I solved for x, and 5/2 is a vertical asymptote. Okay, so let's go ahead and put this in the calculator, and you're going to see that this here is going to look different from the other two. We're not going to study the other type of asymptote for this function. I just want to introduce it to you. So that's x squared divided by 2x minus 5. And I get to graph it. This looks a little different. And if you're looking closely, you can see it has a vertical asymptote, but it really does not have a horizontal asymptote. It has what's called an oblique asymptote, and I will draw that in for you. So the oblique asymptote, let's see here, I had figured this out. I actually had to do long division, and I'm going to save you the agony of doing long division. If you're in Honors Algebra 2, you would actually have to do long division, and you would find that you would have 1/2 x when you divide plus 5/4, and then you have some sort of remainder, but we don't take the remainder. So when I graph that line, you can see there's my oblique asymptote. So you can see that this part is approaching that asymptote, and on this side as well. Remember, an asymptote is where the function approaches. So as far as horizontal asymptote goes, let me write this in blue. Horizontal asymptote, there is none. It has what's called an oblique asymptote. Okay, and we don't study that in regular Algebra 2. So I'm going to go ahead and let's go ahead and sketch this. I'm going to put in my vertical and my horizontal axes. So I know that I have an asymptote right here at 5/2. So I'm going to just go ahead and draw that in. That's my vertical asymptote. And I know from, I was able to give this to you. I know that there's an oblique asymptote that kind of runs somewhere like this. That's my oblique asymptote, and you do not need to know how to get that. But that just kind of helps me to draw the function. And so the function goes, it's like a boomerang on that way, and then on this side it kind of comes down like this. And I just got that image directly from the calculator. This just helps it to be a little bit more in the ballpark. So again, let's just review horizontal asymptotes. If the degree is the same, I take the lead coefficient, and that's what gives me my horizontal asymptote. If it's bottom heavy, it's always y equals 0. If it's top heavy, you can think if you're top heavy, you're going to fall over. So if you're falling over, that's oblique. We do not have a horizontal asymptote. So those are the 3 takeaways from today's lesson.